Alright, so today we're going to be looking at house robber or Leetcode number 198. So let's start from the beginning. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So you're given an integer array which represents the amount of houses and the amount of money for each house. Your goal is to return the maximum amount of money which a robber can rob in the neighborhood without robbing two adjacent houses. So I drew a little picture here so it's easier to visualize because it could be hard to visualize at first just to see which approach we could use. I always think drawing it out is the best way to find out how to approach problems. So if we look here, right, there's this blue thing which connects two houses, and that in this case is the alarm. And the only way this goes off is if these two houses are both robbed. So if this house is robbed and this house is robbed, then beep, 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 the alarm is going off, right? But if this house is robbed and this house is robbed, since this alarm still has one house that isn't robbed, then the alarm will not go off. So that's basically the main constraint, and that brings us to our approach. And it's a dynamic programming approach. It makes me want to throw up. But it's a very useful approach for different types of problems for Leetcode because you take this bigger problem and you size it down into smaller problems. But first, let's look at this example. So the robber robs this house. So far, the max amount of money is 1. The robber can't rob this house because that's two adjacent houses, and then the robber can rob this house. So that's 1 plus 3. So right now, $4 is the max amount of money. And the robber can't rob this house since we already robbed this house right here. So one way is to get $4. Okay, now let's look at another way. If we rob house 2, we can't rob house 1 or 3. So then we rob house 1. So that's $3. But we found out that $4 was bigger. We found a bigger path, which is robbing these two houses. So using this dynamic programming approach, right, we need to see what is the max amount of money that you could rob for each house, right? First, start off with this house right here, the first house, which somehow only has $1 to rob fund, but we don't question it. We rob this house, right? And that is the max amount of money we could rob from that house, right? Because there's nothing to the left. So if we end our array here, that is the max amount of money we could rob from the first house. All right, now let's look at the second house. What's the max amount of money we could rob ending at the second house? Well, if the array ended there, we rob the second house, right? But we can't rob the first house because if you remember adjacent houses, this alarm will go be-doo, be-doo, and we won't be able to rob it, right? And the police will be notified. So we can't do that. So the max amount of money we could rob from this house is 2. And the max amount of money we could rob from the first house is 1. So now we just do that for every house in the array, right? So the max amount of money we could rob ending here is 2. Now we go to the next house. The max amount of money we could rob from here is not 3 because we could also rob this house, the first house. So if we rob the first house and also the third house, the max amount of money we could rob here is 4. And we do this until we get to the end of the array. So the max amount of money that we could rob for the fourth house is not 1, but it's 3 because we robbed their second house and we robbed their last house and we skip every other one, which means that this max is actually 4. So this is my Java code for the dynamic programming approach. We first declare a max variable which keeps track of our max, as I said before, for the different houses. And we return that at the end. That's the main thing we'll return, and we'll update in our double for loop. So then we declare another variable sub1, which we'll use in the middle of our for loop, and I'll explain that later. Okay, so this array is DP, the DP array, which I was talking about, which keeps track of the max of every single house on the block, right? And we'll have a drawing on the right side so it's easier to visualize once we go through these double for loops. And this is a base case just to see if nums is only length of 1. There's no point in going through this because once we start at I equals 2, there will be an index out of bounds error, and we can't have that. So we just return the first number in num since that's the max you could have with just an array of length 1. So we first fill out the first index of our DP problem, right? Because the max amount of money you could rob from the first house ending at the first house is only the amount of money at the first house, right? And the max amount of money which you rob at the first house in this case is 1. We then do the same thing for the second house because robbing the second house means you don't rob the first house since they're adjacent, right? And there's an alarm right here which will trigger if you rob both houses. So the max amount of money that you can rob from the second house ending at the second house is 2. We then declare our max to the max of either of those two just in case the nums is actually the max of the first one and the length is probably only 2, right? And then we return the max at the end just in case nums is length 2. So now it's for loop time, right? This is where all the bulk of dynamic programming is, right? So we start at I equals 2, right? Since we already filled out DP 0 and 1, we start out at I equals 2. So starting at I equals 2, we start here, right? And we're acting like this is the end of our array, right? So we will never touch this because we want to see the max you could get ending at this house, right? And somehow this house only has $3 to rob, but don't ask me. I don't make these questions. So our sub will be equal to num's I, so we don't lose it. So our sub equals 3 right now. And we start from I, right? So we start here in our nested for loop. So here, we're here now. And we decrement every single time checking what the max is, right? So right now, this is J. So then we check if J equals I minus 1 because we can't rob adjacent houses, remember? So we have to skip this house no matter what because we don't want the alarm to go off. We don't want the police to come. So once we check that, we update our sub to see which one is more max. And in this case, our sub is the max of our current subroutine, right? Of our current I. So the max of all of this. And the max would then be updated for this J right here. Okay? So if that's a little confusing, we'll go through it step by step. So our J starts here, and our sub equals 3. And what's the max between 3 and nums I dpj? So nums I is 3, and dpj is 0 since the defaults are 0. So right now the sub would equal 3, right? Okay, next we decrement one more right here. And does j equal I minus 1? Yes, it does, because our index is 0, 1, 2, so it would be 2. And our next index is 1. So 1 does equal 2 minus 1, which means we skip this step and our sub stays the same. So now, since we're at 2, we decrement again. We go to the left one more time, and we now are at 1, right? So our sub equals 3 right now. And does j equal I minus 1? No, it doesn't, right? Since this is 0, this is 1, and this is 2, it does not equal I minus 1. The main point for this check is to see if they are adjacent houses, and there's only one case in which they are adjacent houses going to the left. So no, this test case will only happen once. So once we're here, we see sub, right? Sub equals 3, and we compare it to nums I plus dpj, which means we add the money for the two houses that we robbed, which in this case is 3 and 1. So now sub will equal 4, not 3 anymore. So that is at the end of this for loop now, since we reached the start of the array, right? And we can't decrement anymore since j is greater than or equal to 0. We update our I, right, to find the max ending at the house which we're currently at. And in this case, it's 4 because we update it with the max, which we do have a variable for, which is sub, right? We also update our max to see which one is bigger, the max, which we currently have, or the sub max, which is the max of the subroutine, which we had for 3, which in this case was 4. And we do update it because max before was 2. So now that max is 4, we only have one more house to rob, right? And we do the same exact process, which we just did. So now this is the end of the array. In this case, right, our sub equals nums I because the max for that subroutine right now is 1. Because that is the max we could currently rob starting at that house, right? So now we go to the left one, right? As we're in this inner for loop now, we go to the left one. Does j equal I minus 1? It does. So we still only rob this house and we skip this house. Now we go one more to the left. Can we rob this house? Is it adjacent? Yes, it is. And now we check if the subroutine max is bigger than the nums I plus dpj. And is it? So sub right now is 1, right? And nums I plus dpj is 1 plus 2, right? Because this is nums I and this is dpj, right? Because j keeps decrementing and I stays the same, right? So this is j and that is I right there. So 1 plus 2 equals 3, and obviously 1 is less than 3, so now sub equals 3. We then also go to the left one, and does j equal I minus 1? No. You see, this case, though, is that we skip 2 houses. We don't skip every other house because there could be a case where this could be like, let's say, 50, and then this one would be like 6. The max in this case would be these 2 houses. So we can't just write an algorithm which just skips every other house, because there's cases in which you could skip 2 houses, which you could skip 3, 4, 5 houses to get the max, because then in these numbers, the max would be 56, right, from these 2 houses right here. So you can't write an algorithm which robs every other house, which is what I actually did in my first try of this problem a while ago. But then once I learned DP, I saw that there's way more different cases which you could use. So now once we're at this house, 1 plus 1 equals 2, right? Because now we're robbing the last house and the first house, right? 1 plus 1 equals 2. And do we update our sub, the max sub currently for this whole subroutine? No, right? Because 2 is less than 3. So now once we're out of the inner for loop, we update our dynamic programming I, which is the max for that current house. If we end at that current house, right? So if we end at this house, our last house, what is the max? We update it to sub, right? We kept track of that the whole time, which in this case is 3. And then we see if it's bigger than our max, which it isn't. So now the max just stays the same at 4. And we reach the end of our array. And now we return our max.